JS2 Computer Science Alternative Logic. That's the topic we are looking at. We have already checked standard logic gate in one of our lessons. So any logic function can be simulated using the AND, OR, and NOT. And the AND gate, OR gate, and NOT gate are the standard logic gates. So the functions of these three other gates can be used to simulate other gates. The AND, OR, and NOT are the main operators because they are the standard logic gate. And when any other operator is combined with the NOT operator, it will give another operator, and this leads to the other two operators, which describes what we refer to as the alternative logic gate. And types of alternative logic gate we have three types of alternative logic gates, which are the NAND gate, NOR gate, XOR gate. And the NAND gate itself is a combination of AND gate followed by the NOT gate. When you take the AND gate and you follow it by the NOT gate, that's what we refer to as a NAND gate. Hence, the name NAND is just like taking a NOT gate and an AND gate. That is NOT plus AND gate, it gives us NAND gate. The output from the AND operator is usually the input for the NAND operator. It's represented with a bar on an AND operator, and this is the inverse of an AND operator. What this means is that the output that we get from an AND operator is usually the input for the NAND operator, and this is represented with a bar and an AND gate or on an AND gate operator, and this is the inverse of an AND gate operator. So what you get for an AND gate operator, the inverse of it, as in the negative of it, is what will give us the NAND gate operator. Now let's look at the logic gate for the NAND gate operator. You can see this is a symbol of a AND gate, while this is a symbol of a NOT gate. Now with two inputs, when an input is fed into this AND gate, what we get as an output from this AND gate is what goes into the NOT gate to give us the output here. So when what gets here comes out to what our output from AND gate goes into NOT gate, then the result will give us what we refer to as the NAND gate. So what we mean here is that input A and B into the AND gate comes out and enters the NOT gate, which has a bar at this place. Then our output will be C. Our C will be equals to A positive bar. That means the inverse of the output that we have here. And it's the same thing like saying that here we put the bar only on the NOT gate, but the original symbol for an AND gate looks like it's an AND gate with a bar there. This small dot on this symbol is what referred to as a bar, which stands for the negation or the inverse of whatever the output is. So that means AB, which equals AB bar AB. And our truth table for an AND gate, will be our truth table for NAND gate will be AB, when we have our possible input 0011, then 0101. And normally for an AND gate, in an AND gate we say that we can only get an output of 1 when both inputs are 1. So both of the inputs are not 1 here, so our output is 0 here. Here both inputs are not 1, then we have an output of 0. Both inputs are not 1 here, we have an output of 0. But here where we have both inputs to be 1, then we have an output of 1. This is an output of what an AND gate is. Now, when this AND gate is being fed into a NOT gate, this 0 goes to the inverse, which is 1. This 0 goes to the inverse, which is 1. The same thing with this, which is 1. And this one, which is 1, goes to an inverse. That means the inverse of 1, which will now be 0. So this is a truth table for an AND gate, which means C equals bar A, the negation of the input that we get from an AND gate. The next one is the NOR gate. The NOR gate is a combination of NOT operator with OR operator. Now we have three standard logic gates, and not and or. So when it comes to the NOR gate, it's this with the combination of NOT operator and OR operator, and it is represented with a bar on OR operator, and it is also the inverse of an OR operator. What we mean by a bar is this small dot, which is showing that it is trying to show the negation. So the NOT gate is a kind of gate that consists of this OR gate and this NOT gate combined together to form something that we have like this. So this is a logic gate for an NOR gate. Now the tutorial for a NOR gate, remember in our OR gate, we can only have the output of 1 when both or either of the two input rather, are 1. So when both or either of the two inputs are 1, that's how we can have a 1. For example, here both inputs are 0, so our output will be 0. But here, when one of the two inputs are 1, then we have an output of 1. The same thing here, one of the two inputs are 1, we have the output of 1. And when both inputs are 1, we also have an output of 1. But we have an output of 0 when both inputs are 0. But when either or both of the inputs are 1, we have an output of 1. So since we have said that the NOR gate is an inverse of the OR operator, so this is what we have for the OR operator. So an inverse of it is more or less like the opposite of it. And since we are dealing with binary number 1 and 0, the opposite of 0 will be 1, the opposite of 1 here will be 0, for 1 here will be 0, and for 1 here will be 0. So that is the truth table for an NOR gate, which is the combination of a NOT gate and an OR gate. So after that, the next one we'll be looking at is the exclusive OR gate, and this is the final gate of any significance, and it is manufactured because its output appears so often in computing. So the symbol for the XOR operator is this plus symbol in circle, and XOR operator is also known as an exclusive. This one is the XOR operator, the XOR gate, which is also known as the exclusive OR. And this is the final gate of any significance. This is the final gate of any significance, and it is manufactured because its output appears so often in computing. So the symbol for the XOR operator is this. This is the symbol, just like a circle with a plus sign inside it. So hence, the A XOR B is written as AB with the symbol in the middle, A plus B in the symbol. Then we have the logic gate for XOR gate. In the logic symbol, these are the logic gates. Looks like input A, input B, then and we have the output C. Then the truth table for the exclusive OR gate. Here we have 0, 0, 0, 0, 1, 1, then we have 0, 1, 0, 1. Now, the output of this OR gate is that we can only have an output of 1 when either inputs are 1. When either of the inputs are 1, that's when you have the output of 1. We only have an output of 1 when either of the inputs are 1. When both of the inputs are 0, our output will be 0. When either of the inputs is a 1, we have an output of 1. When either of the inputs are 1 here, we have an output of 1. And when both of the inputs are 1, we have an output of 0. So if both inputs are of the same digit, maybe 1, 1, 0, 0, we are going to have an output of 0. We can only have an output of 1 when either of the inputs are 1. That is the truth table for an exclusive OR. So I'm going to leave you with the assignment for it. Now I have a logic gate here with 3 inputs. Remember, we say logic gate can have 1 or more inputs, but here is a combination of 2 logic gates, which are the AND gates. I'm combining 2 AND gates together here to form what we refer to as a alternative logic gate with 3 inputs, input A, B, and C, and our output will be D. So whatever we get from these two inputs, our result here will be what will be used with these other inputs to get what we have as our output. So what you are going to do is that you are going to draw a truth table for the logic gate below. This logic gate I have under, and your truth table will be having 3 inputs, which is A, B, C. That's what our truth table will have. So at least let me just give you an hint of what it will look like. I'm trying to give you an hint of what it will look like. Since we have 3 inputs, we are going to have A, B, C, which is our 3 input, and at the same time we are going to have the A dot B dot C as another column, and the last one, which is the D, will now be equals to D will now be equals to the bracket A dot B dot C, then bar, the negation of that. So that is a hint of what the truth table will look like. And we are going to have our 0 0 1 1 0 1, no, sorry. We have 0 0 0, and we have 0 0 1 1, and we have 0 1 0 1. So that's how it's going to look like. So do the assignment and submit to the platform. Thank you very much.